We're looking at number 5B on page 324. 2.50 times 10 to the 20 atoms. How would I go from here, guys? I'm trying to get atoms into moles, right? So what's my conversion I'm going to use? 1 mole on top and atoms. Because again, these guys must cancel out, right? Whatever's here has to go down there. Whatever units has to go on opposite sides, so they will cancel out. So therefore, then I simply take this divided by that, and that's why I ended up with a small number, right? This would be 0.000415, right? I hope you see you have to become comfortable or should be comfortable with the scientific notation, right? Because we're going to be using that oodles of times as we go through this chapter, this unit. Does that help? Other questions here? Pretty straightforward, I think. Yes, ma'am. Back to this? Okay. We're cool? Yep. I'll give you another 10 or 15 seconds here. Yes, ma'am.
I didn't understand the first part of the answer for 6A and B.
So they asked you, identify the representative particle for each formula. So CO2 is a covalent compound. So the smallest thing that is a covalent compound is called a molecule. The smallest thing for an ionic compound, zinc chloride, is a formula unit. We don't use those terms a ton, but it was worth putting up there for you. Because you will see them use those terms in the textbook. Okay? Molecule means covalent. Formula unit means ionic. It's just the smallest piece of each of those things. That's all. Ready? We're cool? And again, I will post these up that you can spend some more time there. All right, I wanted to continue a little bit with how small atoms are, right? And trying to get our mind around moles, right? Because that's where we spent our time yesterday, was on moles, right? Remind me again, a mole is what? Give me just a raised hand. What do we mean? And not like the furry thing that digs holes. Okay, what do you think, Lucas? An amount of atoms or molecules or formula units or anything, right? Water bottles, absolutely. It's a group, right? A counting group, okay? And do we have a number? Do you remember how many is a mole? You got it, Nathan. What is it? Avogadro's number is the name of it. 6.02 times 10 to the 23rd, right? So it's a big, huge number. But again, we are very bad at big, huge numbers. Are you comfortable? Like, we think, oh, that's a big number, but how much is it really? So here's an example. I have the continental U.S. here. How much of the United States would be covered if we were to put 1 mole of sand particles on the U.S.? We cool? Again, think a little tiny sand particle, right? And I were to get 1 mole, 6.02 times 10 to the 23. We cool? All right. So if you do the math, you find out that you need 262,000 square miles of sand in order to get 1 mole coverage. I'll save you the math, but that's what it comes down to. Okay, and a square mile, you with me? A mile long, a mile wide, and a mile high is a square mile, right? Oh, excuse me, it's a square. That'd be a cubic. My apologies. Square would be a mile each direction. Whew. Mr. S messing up his math, right? So let's start with some states that you all know, right? So we'll start close to home. We'll get further away. Maryland is about, we are not restarting now. You can remind me later. That's fine. Maryland is about 10,000. I'm doing some rounding here. 10,000 square miles is the state of Maryland. We cool? So let's come back up here. And I'm going to try and draw. Now, again, I'm not very good at this, but we're going to try it. Okay? So, Maryland. Oh, boy. Sorry, I got to go back here. Let's color in our friend Maryland, which is right here. And cool, and a little bit over on the eastern shore. Okay, so there's your 10,000. Okay, but I'm not even close, right? So let's add a few more. We'll put Delaware and we'll put Virginia because these guys are pretty close to us, right? So Delaware finishes off that eastern shore spot. Virginia, pretty big area here, right? So let's color in all of Virginia. Okay. Am I anywhere close yet? No. Okay, let's keep going. West Virginia, Pennsylvania, and New York. How about let's put all those guys in? Oh boy, sorry, wrong one. So West Virginia. There's West Virginia. Here's Pennsylvania. All right. Here's New York. A little geography lesson today too, right? Can't forget Long Island. Okay. You do the math here, though. We're still way short, right? This is 92, 96, 116, 156, 158, 168,000. Like, we're still way short, right? So let's keep going. How about we add in New Jersey and Massachusetts? So here's Jersey. Everything is legal in New Jersey. And Massachusetts right here. Yeah, come on in. Right? But we're still not there. Right? We're still short. That's only 15, add another 15,000 there. So two more big states we'll put on there. North and South Carolina. So here's North Carolina. And here's South Carolina. That much area to get 226,000 square miles. So if I want 1 mole of sand to be dumped on the U.S., it's going to take all of that space. But we're missing one component. How high is the sand? Right? 50 feet high. All that space, 50 feet high, to get 1 mole of sand. You with me? That's a lot of sand, right? So how about we spread it out a little bit more, right? Let's say 5 feet, right? So when we go 5 feet, that's where this lovely map comes in. It's all of the white except for all of the white is covered with sand, except for those 8 states. 1, 2, 3, 4, 5, 6, 7 states, excuse me. Except for those 7 states. If you want to layer 5 feet deep, is that not impressive? You want to cover the entire United States? And don't forget about Hawaii and Alaska. The entire United States, you want to cover it with sand. Again, 1 mole of sand, you're going to be just under 4 feet. 3.95 feet of sand. 1 mole. Are you comfortable 6.02 times 10 to 23 is a humongous number? Right? But again, it's about this much water. This tiny little water bottle. Which again, atoms are small. Very, very small. Are we cool?
How is the sand measured? Like by grain?
Right. So you're taking the size. All this is based upon the assumption of a size, and all the grains of sand are all the same size. You're right. You're right.
So you're saying if the atoms or particles were made a size of sand?
No. This is all just about the number. That's all. This is not about size at all.
So how come you can't just put sand in that bottle and it's a mole of sand?
Good, because we're counting the number of particles of sand. Does that make sense? Let me show you a picture of sand. Maybe that will be helpful. Sand particle. I cannot write or type. I don't want size. Just give me sand particles. Are you with me? So these little guys here, stop. Just the image. right? Each of these little guys would be 1, 2, 3, 4, 5, 6. You with me? If I were to take, if all of these were exactly the same size, which sand particles aren't, but we're assuming we can get them all identical. And I want, instead of however many there are right there, let's say there's 1,000 in that little picture there, I want a mole. I want 6.02 times 10 to the 23 particles of sand. And it would take up. Right. Absolutely. A particle of sand is humongously bigger than an actual molecule of water. Excellent. Are you with me, friends? Did you see, by the way, how big of a difference it made when I added Alaska into this piece? I'm not sure if you've ever seen this before. This is actually how big Alaska is. Because Alaska is always just this little tiny little thing that gets put on the corner of your maps, right? Like this, right? Oh, look, cute little Alaska. I mean, Hawaii is almost as big, right? No, this is how big Alaska actually is. Almost 600,000 square miles is Alaska, 584. It's humongous. The distance from the top, Barrow, which is one of the highest cities, all the way down to Juneau, which is the capital, is the same distance from New York to Orlando. And that's one state. It's a humongous, humongous place. So anyway, that is your geography lesson for today. And again, the point behind all of this is that atoms are small, right? Very, very tiny things. Okay. I am going to stop this recording because that's as far as I want to go with you today, at least